Hello and welcome to another video in our applications of integrals section of our Calc 2 mini concept refreshers. This is going to be on volumes, specifically the disk and washer method. This is used most often in MET 266 and 271 at ASU. So this is our question. It tells us to find the volume of a solid obtained by rotating the portion between these two equations that lies in the first quadrant about the, I should say, x-axis. So the first thing I like to do is draw a picture. Now, once we have our picture, this kind of helps us visualize what exactly we're looking at. Now, what we're going to use here is the washer method. So what we're going to do is we're going to split the volume of this rotated solid into a bunch of very thin disks. So they're going to look something like this. Okay. Imagine that as a circle around the x-axis, right? So if we kind of do a more head-on picture of this, if we wanted the area of this shape, right, imagining that this is filled in here. If we want the area of that shape, if this little radius is little r and this big radius is big R, the area is going to be pi big R squared minus little r squared. Now for us, big R is going to be the height of our, from our x-axis up to our top equation, which is our cube root of x. So that height is just the y value of that function. So in terms of x, it's going to be x cube root of x. So if we square that, then we end up with x to the 2/3. Minus, now the smaller radius, right, is the distance from the x-axis to our lower function, which is x over 4. So that's just our y value, which again is just x over 4, and this is squared. So I'll write this as x squared over 16. So all we're doing is we're integrating this expression. I'll pull the pi out front, x to the 2/3 minus x squared over 16 dx. And we're going from x equals 0 up to x equals 8, which is where the two equations meet. And now we can just solve this out. And when we plug in 0, this will just go to 0. So when we plug in 8, we end up with 128 over 15 pi. And that is going to be the area of our rotated volume. Thank you for watching this mini concept refresher in our application of integrals section. Next up is going to be the other method of calculating volumes, which is by building shells, cylindrical shells. You can visit this link for more information and resources on the ASU Tutoring Center. Thank you for watching, and I hope to see you at the next one.